All right, good morning, everybody. I'm super excited to be here today talking about how math works in JavaScript. Hope everybody had their coffee. And specifically, we're going to talk about addition. So when I was writing this talk, I did what any programmer would do, and I Googled JavaScript addition. And literally the third hit was this rather poignant Stack Overflow post that says, addition is not working in JavaScript. So here's this poor person, they're trying to learn JavaScript, and they're doing what they think should be a fairly straightforward thing, right? Just trying to add two numbers together, and they're getting an unexpected result. 2 + 2 = 22, 5 + 7 = 57. And they're especially confused because division, multiplication, and subtraction are all working just fine, but somehow addition is not. And I really felt for this person, because this is legit, right? Like here they are, they're trying to do some simple addition, and JavaScript is violating every expectation they have about how math works. And it's not just beginners who feel this way. This is a slide from a lightning talk Gary Bernhard gave a few years ago called What, which if you haven't seen, I highly recommend. And it's basically 4 minutes of him pointing out a bunch of ridiculous things in JavaScript and in Ruby that basically make no sense, including this rather bizarre math. So I watched this talk, and I felt kind of like, GIF upcoming, I felt kind of like this. So fortunately, the talk does not end here, because once I got over my complete crogglement, I decided, you know what, somewhere buried inside this language, there is a reason that JavaScript acts this way. So we're going to go on a little adventure with our friend Donald Duck here, and we're going to figure this out. So hi, I'm Meara. I live in Chicago in the United States. That's my Twitter handle there in the middle, and I work at a consultancy called TableXI. So before we go too deep into the internals of how JavaScript handles math, we probably want to be clear on what the things are that we're doing math with. So we're going to go through a quick overview of the basics just to make sure we're all on the same page. So we're going to learn about object types. There's a few different kinds. So JavaScript has 6 primitive types, basically the building blocks of the language, and we're just going to breeze through them. So the first primitive type is a Boolean, and a Boolean can be only one of 2 things, which is true or false. We also have numbers. In JavaScript, we don't distinguish between integers and floats, and we also have a few special things. There's plus and minus infinity, which we're not going to worry about for the purposes of this talk. And then this thing called not a number, which is what this nan stands for. Fun fact, if you call type of on not a number, you get number, which is hilarious. It's not a number, but it's a number. We also have strings, which are pretty much anything you put in quotes. And of course, there are objects, which can contain both data and behavior. So objects can have a lot of stuff in them like this one, or they can be empty objects, which we would represent by a pair of curly brackets. Null represents nothing, which is different from undefined, which is what you get when you've declared a variable in your scope, but you never actually set a value. JavaScript also has a bunch of different types of data structures, but for the purposes of this talk, we only need to worry about one, which is array. So an array you can think about as a collection, and it can be a collection of all one type of thing, like this array of integers up here, or it can be a bunch of different things like the second example. So all right, so let's do some math. So we've got a few examples here. So this is the participatory section of the talk. So just shout it out, what do you think the JavaScript engine is going to give us when we give it 2 + 2? 4. Okay, you guys are rock stars. How about apples plus bananas? Apples, bananas. How about string 2 plus string 2? 22. Okay, you guys are breezing through this. So as we can see from that last slide, plus actually means 2 different things. So the first one is number addition, which hopefully we're all familiar with. And the second one is something called string concatenation, which if anyone isn't familiar, it's just basically taking 2 or more smaller strings and smushing them together to get one bigger string. So all right, we're feeling pretty good. So let's try something a little more interesting. So what happens if we add numbers and strings to each other? So what do you think is going to happen? Again, just shout it out with string 2 plus number 2. Okay, we got some 4s, we got some 22s. 22, okay. How about number 2 plus string 2? Do we think the same, different? Okay, 4 seems to be the leader. 22 again. How about 2 plus apples? 2 apples, okay. So this is interesting, right? So basically what's happening here, no matter what order we put them in, anytime we're adding numbers and strings, JavaScript is going to turn anything that's not already a string into a string and then do string concatenation. So as we saw in these first couple examples, it doesn't matter that in the first example we're calling a function on a string, and in the second example we're calling it on a number. It's doing string addition either way. And the way that it's doing this is through something called coercion. So we never actually told JavaScript that we wanted it to convert anything to a string. It basically just looked at the expression we gave it and said, I think you're trying to do a string thing. It looks like you're wanting a string, and so it gave us one, which is very, very magical and not confusing at all. So at this point, I think we've got enough data to come up with kind of a working model of how addition works in JavaScript. So for the expression a plus b, if either a or b is a string, we're doing string concatenation with coercion if necessary. And then otherwise, if both a and b are not strings, we're doing number addition. So at this point, I'm feeling kind of like this. We've got this great model, we're cruising through this, so let's try something a little more interesting. What if I want to add some other things? Okay. So what do you think the JavaScript engine is going to give us, or what might you want to get when you add these 2 arrays in this first example here? Okay, we're pretty quiet. I personally would want an array of 1 through 6. I don't know about y'all. So let's see what we actually get. Okay. How about true plus true? I know you're awake. 2. Okay, 2 seems to be the consensus. All right, there we go. Undefined and null. Object, object, 0, laughter. Not a number. Okay. How about null plus null? All right, we got a lot of different answers there. So 0. Okay. How about empty array plus empty object? Any guesses? Okay, we got, sounded like empty string, object, object. Object, object. That is the string representation of an object. And how about the reverse here? How about empty object plus empty array? Anybody feeling confident? I heard a 0. Whoops. Sorry. I am good at tabbing. And the answer, in fact, is 0. Yes, that is what we get. So that's interesting. At this point, I'm feeling a little more like this, right? A lot of those examples did not make a whole ton of sense. It's getting a little scary, but it's okay. We're going to hit the books, and we're going to do some math, and we're going to figure out what the heck is going on. So the authoritative source for what the heck is going on with JavaScript is the ECMAScript specification, which is a very long document put out by the people who write the language about how JavaScript is supposed to behave. So let's see what the ECMAScript specs tell us about the addition operator. It's lovely. This is a lot of text. You don't have to read all of this because I have very helpfully boiled it down to the definition we're going to see on the next 2 slides. So here we are now with a slightly modified version of our model. For the expression a plus b, if either a or b is a string, or its primitive's default value is a string, which is something we're going to learn about soon. We're going to do string concatenation, and if we need to coerce either of our operands to strings, we're just going to go ahead and do that. Otherwise, if both a and b are not strings, we're going to do number addition. And again, if we need to do coercion, we're going to go ahead and do it. So this is great. So now that we have our model, let's go back to our examples from before, and let's figure out how we got those results. So I don't know about you, none of these really look like strings to me, so I'm going to assume we're going to try and do number addition. So let's give that a shot. So here is the table that ECMAScript provides for us on how to coerce these things to numbers. Undefined goes to not a number, null goes to positive 0. In case you were wondering, yes, there is a negative 0. Why is there a negative 0? Reasons. For Booleans, we will get 1 if the value is true, or 0 if it's false, which makes a lot of sense if you think about bits. Numbers are just whatever they already are. Strings we don't have to worry about because we're never going to be doing number addition with strings. And objects are a little more complicated, but I feel like we've already learned some useful stuff. So let's go back and take our new knowledge and do some math. So already, just from that table we just looked at, we've got 3 of our 6 problem children figured out. True plus true turns into 1 plus 1, which gives us 2. Undefined and null, that's not a number plus 0. And when you add anything to not a number, it will still not be a number. So that stays as not a number. Null plus null, 0 plus 0 gives us 0. But we've still got our 3 other examples. So let's go back to the first part of our definition. So before I condense this definition, literally the first 6 or 7 steps are how to determine if a or b is a string or should be treated like a string. And it turns out the first thing we need to do is call this theoretical operation to primitive on our operands. So here it is, and unsurprisingly, if we look at this table, we see that anything that's already one of the primitive types doesn't change. So Booleans, undefined, nulls, numbers, none of those should ever be treated as strings. Strings, as we know, are being treated as strings already. And so basically all we have left now is object. And in order to figure out how to handle object, we're going to call an internal method called default value. So here is the definition of default value. And basically what this does, excuse me, it takes an object and tries to turn it into either a number or a string. And for the way it's being called with addition, it's going to try and turn it into a string first. So almost any kind of object, including arrays, is going to be treated as a string. So if we go back to our examples, for this first one here, we've got these 2 arrays. We're going to coerce these into strings, and then we get an expression that we know how to deal with. And then we go right ahead and we do string concatenation, and we get the result that we saw. So here again, for empty array plus empty object, we're going to go ahead and coerce these into strings. So we have empty string plus the string representation of an object, and that gives us the string representation of an object. And so this is really great. I'm feeling really good about this. But we've still got this one little mysterious example down here at the bottom. And for some reason, this example seems to not be following any of our rules. So what's going on here? So it turns out there's something I didn't tell you about JavaScript. Something I feel like JavaScript doesn't really make very obvious, at least not to me, but it turns out that the plus sign just by itself casts anything to a number. So you can prefix literally anything with the plus sign, and it will cast that thing to a number. So at this point, I'm feeling kind of like this. You know, what is happening? What is reality? I don't even know. But if we go back to our example, empty object plus empty array, you know, I'm still not seeing quite how we're getting to 0, and yeah, it turns out there's one more gotcha, which is these curly braces. So this whole talk, I've been referring to this as an empty object because that's what I think this is. That's certainly what I intended it to be, but actually this notation is ambiguous. So a curly bracket can represent an empty object, but it can also represent an empty block. And a block, as we know, is just a group of code, which means an empty block is just a group of code that does nothing. And so what happens when the JavaScript engine sees this code is it says, well, this is just a group of code that does nothing, and then we're going to cast an empty array to a number, so we should get 0, right? And we do. So hooray, this is fantastic. But what about our poor friend on Stack Overflow? Have we solved their problem? Why is addition so different? And so if we go back to the ECMAScript specs again, this time for multiplication and division and subtraction, you're just going to have to trust me, follows the same pattern. We'll see that unlike with addition, there is no if-else here. So no matter what your input looks like, if you're doing multiplication or division or subtraction or even modulo, you are always going to coerce things first to a number and then do whatever the operator tells you to do. There is no concept of string multiplication or string subtraction or anything like that implemented in JavaScript. So you may be wondering, gee, it's great, I know more about JavaScript addition now, but what happens the next time I'm feeling like this? Or maybe like this? Or maybe even like this? And there are things you can do. So first, the step one is experiment, right? Like play around in a REPL, try things out in console, do all the weirdest things you can think of to gather data about how whatever you're trying to learn about works. Step two is to guess. So make a guess about what you think is happening. In science, we would call this a hypothesis. In this talk, that was the very first model that we came up with. Step three, iterate and research. So, try and break your model. If you're lucky enough to have documentation available, read it. That's generally helpful. And then go ahead and refine your model from there. And step four, hopefully, is that you understand. And then you too can have an awesome dance party like Donald Duck. So that's pretty much all I've got. But before I go, I just want to say thanks to all these lovely people who helped this talk come to be, as well as my company, TableXI. And if you'd like to learn more about anything I covered in this talk, go ahead and check out these references. You Don't Know JS is a great book series. I really recommend it. And Mathmagic Land is on YouTube, so give it a look. Thanks.